So, as you know, we are programmers. We have also software programming tool environment as format for our slides. I'm field engineer, and I work for Unity, and I would speak about how to write correctly code for Unity or in Unity, and what you can expect next year in this respect. We cannot promise, of course, 100%, but actually quite a lot is almost ready. Are you a programmer? Who are? Quite a lot. But please raise your hand if you never raise hands. Okay, this is a product. Okay, so what I'm going to speak about today. We as Unity are interested that you, developers, would produce great games based on Unity. And of course, you also might be interested in that because nobody wants to write the bad games. Of course, you would prefer your games to be better. And a good game has certain attributes. I cannot remember all of those attributes, but because we are programmers, we think first of all about code, about speed of execution, about lack of lags, and so on. For us, it is important in Unity. It is important that you would understand how to write correctly code in Unity that is fast executing. And as you know, we are not training in that. You could visit our website, and there is a section devoted to learning. And this is anyway for a starter programmer. And we explain in that section how you can use objects, you can compose something of that, you can add some functionality on top of that. And that is how games are created. But myself, I communicate quite a lot with programmers. I visit different studios, conferences I attend. And from time to time, people tell me that, we use Unity, but we do not use that to full. We only use it for some rendering. We do not use game objects for our needs. And I hear that. I hear such feedback, and it's not the good Unity way, not the full use of Unity. And that is probably caused by some misunderstanding of lack of knowledge. That is not Unity way. Using Unity is not correct. It sounds paradoxically, but we want you to use Unity to the full. You should use it to write effective, well-executing code that would be executed in different devices. So how you can write a code that would be effectively executing in modern-day devices, like I here have a 4-core device, 8-core processor you could use, and how you could write in Unity using multi-thread approach, and to do it safe so that there are no lags or mistakes. Well, you could, of course, copy some other codes into that, and that for many, nevertheless, remains only a single-thread environment. But what can you do in order to use all the cores of the processor to really do multi-thread, to use more resources available to you from the processor? So I have listed here some of the things that you can undertake to correctly structure your data, first of all. Processor expects data prepared for processing. You need to learn how to write a multi-thread code that would be run in parallel, and it would be great if you could use some tools so that Unity would generate a faster code for you. That is executable code, I mean. And for this, we need to propose a number of answers to these questions. First of all, in order to answer the first question, data-oriented design, I would touch only upon part of it. This paradigm, data-oriented design. If you haven't heard about that or didn't read about that, I recommend that you Google for it, and in order to get understanding. This is how you structure. That's about how you structure your data, so that processor would find it easier to process these data. We currently work on a system that we call some job system. C hashtag job system. Probably you heard about that, but with Unity 5 version inside our code, we have job system, which is not available to you as a programmer, and this is for our subsystems code writing, but you cannot use it for your system. And now we want to provide to you this possibility to use job system and a compiler that would accelerate that several times, several-fold. And in order to use a second and third item here that you see on the screen, you need to understand better what is meant by the first item. So you need to understand how to consider your code from a different point of view. And I would like to demonstrate now to show you a demo. This is a video clip. And video is a project, actually, that is made in Unity. It's a simulation of a school of fish, like autonomous objects that follow some simple rules. Like birds sometimes follow the same chaotic movement. It seems chaotic, but really they are very well organized, avoiding obstacles. Here you can see a number of such objects that fly around, and they avoid hitting an obstacle. And here in Profiler, you can see in timeline that everything is done in the main thread only shown here, and the rest cores are not yet enacted, not yet doing anything at that moment. So instead of fish, we can use just squares here, because my MacBook would not be able to handle some more accurate objects in such number. That's why we decided to simplify the task and use just squares instead. So what we could do next, when we use job system, we could write code that would distribute all that behavior or split it up into parallel threads that would be processed by other cores of the processor. Here you can see we added some of that, and there is certain slowdown. So we can simulate only part of those fish. And if we include job system, you see that it's much more effective. Split up into cores, part of such simulation would be running much faster if you really use our subsystem, which is called job system. You could use this for yourself, and then your code would run much faster. That means you would use capacity of your processor, multi-core processor, much better. And we also work currently on a new technology that would allow to compile that also much more efficient. And I added quite a number of new objects, and if we increase the number, we have again slowdown. And if we connect this compiler, that increases the processing speed even more, and we could extend the number. You see there are huge number of objects now, and nevertheless everything runs more or less smooth. Compare the first number that I showed originally with this one. It's much bigger school of fish, or number of objects, and this is something you can do if you use our subsystem. And that not only for that simulation, of course, but for other tasks that you have in hand. And now let us go back to presentation.
Один слайд.
So one of the slides is about the design, on the data sequential design. So what makes contemporary processors so special? What they like is to have data ordered, because they do not process just pieces of data, they process just the bulks of data in cache. So the most part of the data will be taken from the cache, and thus it will work faster. However, if we have mono behavior for game objects, we have a list of game objects, and we have the body of indicators. And these indicators are somewhere, so every time the processor has to address the memory and take out everything what was in cache, which takes up a lot of time. And this is how us, programmers, are doing the code. This is how we teach how to write codes in beginner tutorials. Because our key task is to rotate the object with some speed. So we have speed, we have update. So we have transform rotation, we multiply speed by delta time, and it's less simple. It becomes more complicated when we have more objects. And once those are just numerous, we see the overhead of the update methods. Many years ago, I wrote the following blog post, which explains where we have all the cycles, why all the cycles are gone for the updates. I met many programmers and developers who were trapped by this mistake, and I believe that less and less people will be trapped by these mistakes. What should we do to take away these updates? The most simple way is when you have several numerous identical entities. So you can just retrieve updates from this manager or just have all the logics transferred into manager. So we have the rotator. Now it has a reference to the manager. It has speed. It has the capability to structure the speed. And when needed, it gets a reference to the manager and has a cross-reference with the manager so as to retrieve the logic. Let's look at the manager, have the body of components, and has update, which means that in update it does all the rotation logic instead of retrieving the rotator functions. So all the logic is done there in the update. And the manager covers all the components and implements the transformer by multiplying speeds by delta time. So this is what we have instead of what we used to have. We have data storage and a manager that uses data to transform them. And this is how we are moving towards the entity component system. The key idea is that in this pattern, you have all the logic and components. Let's look at what can we do about the data in the entity component system. This implementation is a project that we are doing in the Unity, and we will make it available for usage. As of now, we have some ready-made solutions. So let's look at how the code changes. So it has only data, no codes, because we need data in the components. The data is in the rotation system. And here we have some syntactic components, which means that this is the component system checks that there is synchronization of transformers and rotation speed components. So once we have some rotation speed component, the system recognizes it. And this is how we have transformers. And then we do the same thing in the update. We just cover the collections. And you have the same code that does the rotation. The code rotates the objects, but in a different way, in the entity component system mode. So as you see, nothing is left from mono behavior. There's only data storage. So we can get rid of the mono behavior at all. In a vast variety of cases, we just join mono components to game objects because we just need them in a specific scene. To get rid of these components, instead of the game object, we establish a structure that has speed. That's the data storage structure. It's not mono behavior structure. It's not integrated into the scene. To join the structure with the game object, we need some operation that would adjust the speed on the one hand, and a system. The system that's responsible for a rotation is basically the same. We have transformers, we have the collection of data. So you see, it's just not one rotator, it's just an entire system now. This is a tool that has many advantages. We have sequential data, something necessary for the processor. We have game objects and components. I have this component, but we may sometimes not need it because sometimes we may have a hierarchy which is independent from game objects. The best thing is that next we can use a job system to transform the component system so as to be able to ensure that rotations are done at different streams. So here we have two collections, once again, one with transformers, other with rotation speed structures. And then in update, we create a job, we tune it, and then tell the computer to do the job. A job is a structure that has a list of rotators to be done and the execution method. So this is how the code has changed. Instead of having the same code in the update, we establish a job that will be carried on, that will be delivered at some time in the future. Once again, what job is basically? Just a short and simple example. Well, let's call it not jobs, let's call it by a Russian word after all. So what we want is to have a float massive, a float body of data, and we want to copy it into a different stream. Therefore, we establish the following structure with an iJob interface, which is basically the execute method. We establish two collections, and I'll tell you later what are those collections responsible for. And then we have the execute method to copy one collection into the other one. So the code is basically simple. To launch this code, we first solidify this job. So take this collection, take that collection, we launch it, and have some handle that we can process somehow in the future. For example, we tell the computer, do the handle now, and the system decides how to perform the job. And you have the result immediately, instantly. To this end, we have a number of several collections. This is just the same body of data, but those are not structures. They are not responsible for location. It is the native part which is responsible for location. Therefore, you have to take care about the memory yourself. That's one thing. The other thing is you can indicate how you want to use this body of data. We have a set of locators here. Depending on the type of data. So you can indicate here how you would like to operate this body of data. To make the code code writing process simpler, we have several jobs. This job allows us to launch the cycle and to cover the body of data on different streams. Instead of having the cycle here, we have the index here, and we copy the resource into the destination index. We have several native arrays. We launch those, however, together, but separately, so as to have 100 items per each bunch. So we have several sets of just calls, 100 calls, the other 100 calls. And the same thing stands true for transformers. If you want to change transformers in your parallel job, you should make it differently. Hence, iJob parallel for transform and execute. You see execute, you see indices, and you have a platform, transform access platform. I'm not going to focus on that in more detail, but the basic idea, the gist is that this specific transform allows you to modify transforms. So what you have here is not a transform object that you can see in Unity. And basically, it is just identical. You change the rotation. A very important issue is that once we have jobs, one of these jobs may be not exciting. So we need to establish some dependencies to this end. So we calculate, then we need results of something, then we need the results of something else, which means that there is a hierarchy, and we have to be correct with indicating dependencies. Let's look at a case. We have two jobs. Here we do the first job. We use copyflow, copyfloat's job. So this code is familiar. We take the first handle, add schedule, then do the body of data where we will perform this job. And then for the other job, well, I'm just looking for the right word in Russian. When we are planning this job and its execution, we indicate that there is a dependency, and the system decides how to perform it. So we tell the system we need the results of job 2 instantly, and it is the system that decides what to do first, what to do second. Just to give you an idea, the key thing is that this system must be fail-proof. In Unity, the paradigm is that Unity should be a simple interface that allows to make games without taking care of some mistakes and flaws. Therefore, if you are doing something wrong, we will tell you, you are doing wrong. Failures or mistakes like that can be avoided by way of the job system architecture. Once you're trying to do something wrong, for example, you have located the collection, a Unity will tell you you forgot to process it. Or once you have located the collection, you have two jobs that are they're including data into it simultaneously, the Unity will tell you there's something wrong going with the two jobs because the results are in one of the same collection. So we ensure that you do not fail. In a multi-stream system, this is a highly complicated issue, and a not simple one, by the way. So many of you might inquire, what kind of a magic compiler that is, that just augments speed. Jobs are structures, therefore, we include all the data that will be processed within the specific job. And these data has to be exempt of all sorts of references to objects. This means that we have a limited subset of language possibilities. We do not have any garbage collections. We don't have any virtual functions. And this means that we can take the code, the obtained code, we can optimize it because we know more about what this code should look like, what it can and what it can't. So you take a job, you add an attribute, and all of a sudden it goes faster. The compiler can see that we want to optimize the job, and this is how we can use it within the job. Therefore, we can tell the compiler how precise calculations should be, like synesis. Well, for example, a fish is just moving, so it's not important for us to know the tolerance of its direction. We can just indicate that it's okay. Just wait, it's 12:29, which means I have 15 minutes more, right? Am I right? Yes? Yeah, that's right. Correct. I'll just give the floor to Anton. We have all planned. We have just a time schedule. I'm sorry for such a long introduction. I'm just trying to explain it.
I am actually completing my part. So first of all, we have this, and then we have also a new library with new mathematical functions that support, emulate syntaxes of shader programmers know that those float 2, float 4 and new implementations of old methods we also have available here. And the code written this way, a compiler can sense and generate even faster code, vectorized code that would be processed faster. That is very cool. And the question is when it will be made available, when we can make it, make use of it. Sorry. System library is a C# project, and we want to release it as fast as possible. As to see hashtag job systems, we aim at beginning of 2018 to release it, and we will also do preview before that, preview release that would allow you to test it before it is official public release. So we hope that would make it popular faster. And this is the end of my part, and I give floor now to my colleague Anton, who will speak about some more interesting things. Hi, I will speak about physics a little bit. I am from R&D department. I do everything related to physics, and here I would like to support Valentin's information and using certain examples of how that could be used very soon in Unity, and you can observe it. A little bit of physics. Unity physics, do you know something about that already? Okay, very good. This is an example from documentation. Here we speak about the class. Every class can process geometry, arrow, cross point. That is done in the main thread, because this is done only in the main thread. And then the scripts also were in the main thread. They call up this function in native code, and that is then launched in the main thread as well. Where you can meet it besides documentation. That could be code of your monster, for example, that you create. And in simplest way, it will be calculating the position of the monster using the arrows that are crossed in relation to the land. How optimal is that code? In some cases, this is really ideal. I have just a few lines of code, and this is very simple, relatively simple, and very effective. When you face this problem, we believe that the most complex, difficult problems when you have to scale up. If you have one thing and then you make it 100 times bigger, then it becomes much more complex. Simpler, smaller thing is easier to process, but then if you do it, it becomes a real monster. And what if you have 100,000 of monsters? My colleague spoke about what we can do running that parallel. Besides that, there is overhead related to calling up of that physics function. But more important thing is that as a rule in game code, we see a pattern that we are ready to say we know what we want to process, but we don't need it right now. There is a code of monster. I know how to compute it, but then I can compute something else, and parameters for sound, some parameters for animation, anything else. And then a moment comes when I definitely need to process this. How can you go from what is available here to this new approach in reality? This code is a little bit awkward because all casts are located in different positions of this code, and each monster is a separate class, and there is no manager for that. They're not grouped anywhere, and their dependencies is not clear. It's not clear how long you'll have to wait and what you can insert between the two events that happen. And we thought about that, and we believe that we could use here for this task is this C hashtag job system. It's logical. In this code, there are 3 parts, 3 lines only, but this is actually 3 different parts that will become bigger layers if you use it in multi-thread. The first part is you prepare the source data, starting data. You form the arrow, you calculate how long the arrow should be, when it will be crossed, And if we speak about physics, that could be anything else, not only just geometry, simple geometry. You calculate all these positions, and then you say, okay, I have to calculate that, and then I wait until it is ready, and then you get the result. So 3 parts: configure, call up, and get it done. And how it looks now in multi-thread. Now it can look like this. It's quite simple to understand, although we have quite a lot of code now, but logical parts are the same. We use a number of massives, data sets. Some of them have input data, some output data. It could be cast, raycast command. It could be other commands. Then we fill up buffer of the command. In this case, I filled up just one, but you could have several buffers like that. And if we say like 1 comment per monster, that's quite a big number. And then you say, I want to schedule this work, and you have handle for that. There's a modifier of task. You could save that. You could copy that anywhere you like, and then you can calculate code that you don't need the result immediately. It could be a animation, it could be anything else that would need that. And as soon as you understand that what you want right now, you take job handle, and then waiting is arranged to that. And when we do job handle complete, we understand that it all is done the way we like it. We have a small demo, and right now I will show it to you. This demo resembles the previous one that you have seen from Valentin, but there he used the structures in space, and it was not possible to effectively avoid obstacles. There was smoke and mirrors hiding the facts, but here we have much clearer picture that really shows how we avoid obstacles. 25 milliseconds, the total cycle, and it's originally was run on the main thread only, but you could reduce it and make it more effective down to 2 milliseconds the job if we use multi-thread. The acceleration is quite considerable. And this is the Viking village, which is submerged and 200 frames per second. It was not possible before with Unity. Now it is possible. But how? With multi-thread. One additional remark. This signature function is used to plan the batch, to schedule the batch. Recasts are scheduled in this way, and that is the function to use. There is a parameter, a last parameter, attribute that I didn't speak about yet, that is dependence. You can define that there's batch, and that is supposed to depend from another task. Why we need it? Because we need to saturate that flow of computing. I want in main thread only scheduling, but not configuration of data, for example. And then you say here that there is a batch that's 800 size, and the parameters will be calculated for that by a different thread. And then you have 3 tasks in your chain. One will be calculating parameter, the other will be doing processing of recasts, and the third would use that all in a chain of items processed. And everything works very safe and smooth. Next item. We started to use C# job system in other sections of Unity, and it became clear that the good task is to reduce the thickness of our native layer, to move parts of it to C#, and you ask and I can answer. It is necessary to configure Unity in a simpler way so that there are a smaller number of books, and you can take any component and modify. You can replace it with different one. You could do the same next to it. Earlier it was not possible to modify native code in that way because you don't have the source for that. Like Yakovlev, for example, we could do it now with the help of this approach. which systems can do it now, Yagui, but it's not exactly the same. And the system that use more C hashtag, the way we explained for multi-threaded processing. And one more example with hardcore. We decided to try, let us write all our joints in C hashtag. Spring joint, for example, we remove our native component and would write everything in C hashtag. Everything will then work in multi-thread, and we'll see a pattern. Pattern looks the same. Arrays we can see, and then a manager of sorts. So that is a job parallel 4. It's a task for one joint. There could be 800, say, of them, and they are grouped in packages, 10 pieces in each, in one thread, because it makes no sense to calculate one atom. Our head will be too large. We have to group them into 100 or 10 pieces in one packet. And then we use mathematics. We calculate vectors then, as you see here in this example. We did that. And then we get code in C hashtag working faster than the native code. Can you imagine? And that will be even faster as soon as we'll be able to use more locations in our new compiler. That was explained by Valentin. That means that all C# we can now redo in C hashtag job system, preserving and providing safety too. Thank you to you all for listening, and thanks to organizers for this invitation. Thank you, Anton. Thank you, Valentin, for your presentation. And now we are ready to go over to questions. Please, all questions to the microphone. Speak into the microphone. Thank you very much for your presentation. As far as I understand, the main difficulty with Unity right now, this multi-threaded, that Unity API is not available in other threads except the mainframe. This synchronization is a constraint here, or with the current version of Unity? That's a very good question. That is related to the fact that our API is not thread safe. That means there are a number of common objects. For example, in physics, there's physics, and when you modify the rigid body, position something that goes inside physics, and it doesn't allow a possibility to write it from other threads. I can cite a number of examples. Say animation has the same constraint from that point of view. So that's we would do that in your customs threads, give you such access we cannot, and see hashtag we also cannot. So that means redo the whole API for the threads that you do, like new threads actually, and the whole Unity API will be available there, or just part of it in jobs. Well, this is a good continuation of the previous question. No, API would not be more accessible, more usable, because the safety would not be guaranteed. Systems are redone a little bit. They could then, after such being redone, they can work with C hashtag environment, and you would not have to read data from singleton address in memory all the time, or some other. So only some parts, some things will be available in jobs. Okay, and then can we use the same API in usual C hashtag, or we'd have to go also through job system? That depends on architecture of your application that you're creating. That means theoretically they will be possible. Okay. Next question. Are there any other questions? Don't be shy. Don't hesitate to. Okay. All right, maybe a little bit abstract question, but as Valentin said, tutorials that you have, that you provide is not really applicable to real life, especially for big projects only if you do something small for yourself, then, so do you plan to prepare something explanatory so that people could master that faster, what you can really get out of Unity? Thank you very much for this very good question, too. I think, yes. The problem that we face is that there are two sides of this medal. We could do tutorials that would include all that code and explanation, and then new people would use it for their own engine. They would write their own engine based on that and not use Unity. More questions? Thank you for your presentation. I have a question about physics of job system. You were speaking about joint. If I have 800 related to each other joints, that means the job system would not be effective then if I have those dependencies, because the result of one would have to calculation result of one joint completely would have to be transferred to the other joints. So it's like chain of 800 links, and I push it from above. I cannot calculate middle a link because I don't know results of calculation of all previous links in that chain. So would that be effective for that system, for such a long chain? Yes, there is some misunderstanding. I didn't demonstrate it probably. In my example, I showed 400 of them, and each joint was like a cube, and sphere was attached to that. Those were separate islands. Speaking about physics, they were independent. And that was first thing. And that could be simulated, modeled in different threads. In Solver, we have two stages. First, we do configuration, and then you do computation. Computation is to be done in certain sequence, but configuration can be done without sequence, so that you could jobify that. And probably the last question we can allow. The most important last question, who would volunteer? Can you speak a little bit about how the internals, how this multi-thread is actually designed in your system? Do you use mono multi-thread approach? I didn't get your question, unfortunately. Could you repeat once again? Can you speak a little bit about implementation, how you manage to do that under the hood? What do you mean under the hood? Well, multi-thread, how it really works. Well, in 2 words, this is not the multi-threading that you really use that when you create each thread on demand. This is a different concept. It's like you have a list of waiting tasks, and each of them has to be processed in the same thread. But you can take some parts of that waiting list and process them parallel on a different thread. And so this is a different approach. We have job handle not complete. It's not that you have a busy wait after that. You could write something meanwhile there, and you can take then a different task. It's model based on cooperation. 2. So that means while you're waiting, you could do some other task, and that means you're not spending cycles of processor idle. That is a different paradigm. That is not really a thread in the classical form. You add up tasks in this configuration, and there are other things to that. Atomic safety. It's quite a big topic. It's not for this audience and not that time frame that we are given. Thank you. And the very, very last question, 1 more minute we have. Okay. I would like to ask about job systems that are oriented towards the client applications, right? If we use some headless instance for our server needs, in fact, multi-threading would give us advantage because if we have 8 cores, we have 8 instances of servers that could be stored there. If in some magic I would start using job system in server code, would they influence each other? And if yes, how much?
Well, thank you. It's just a very technical, very specific question. I think the situation is like that. Well, for example, yes, you have a cluster, and it calculates the simulations. It has a 10 millisecond slot. It's wrong to think that with the job system is going to operate for 10 milliseconds. It will operate for 1 millisecond, much faster. Yes, that's true that now we will have jobs across threads and there will be other simulations, but it's wrong to think that we will have some discrepancies because of that exactly. Thank you. Once again, may I extend my gratitude to Anton and Valentin for their report. Well, it's in a different order. Valentin and Anton, thank you very much for your attention. Thank you.
We have many great people here at 4C today, and here's one of them. Hi, please introduce yourself.
Hello, I'm Alexander Markovic. I am Creative Director at Ministry of Games, and I'm here to talk about city building games and design principles of those.
Nice. Do you remember your very first video game that you've played?
Sure, it was The Prince of Persia back in something like 89 or whatever it would have been. Yes.
It's a great game back in the day and still. What's your favorite game of all time today?
I guess I like mobile games, so at the moment I think my favorite game would be probably something like Brawl Stars or Clash Royale, so Supercell PvP titles, or on the other hand some city building titles like Township.
What do you think about the state of modern video game industry overall?
Well, I guess there is a lot happening at the moment, which is awesome. The core games are doing awesome stuff. The casual games are doing awesome stuff. So I think it is awesome that inclusion is happening on all sides, right?
Anything that maybe irritates or saddens you, something that you don't like in the state of game dev today?
Well, the only thing that might sadden us is the sometimes there is a bit of lack of inclusion happening, and sometimes there is a certain amount of kind of toxic behavior that occurs in the gaming circles. But other than that, I think it is just moving in the awesome direction.
Well, it is moving in an awesome direction, and we're here to try and foresee it. Speaking of which, what do you see happening in the industry in like a 10 years' time? What will be the new thing, the new trend, do you think?
Well, hopefully the mobile games stay relevant, right? But other than that, obviously AR and geolocation games are super interesting, and stuff that's happening with that is super exciting. And also, hopefully as things move forward, we get more inclusive or like more engaged worlds that we kind of play together in with each other. And I think this is something that we're hopefully moving towards too.
Well, you're part of the industry. You can help move it forward. Speaking of which, how did you end up in the industry? How did you come here?
Well, I guess as anyone else, I just kind of liked the whole idea of the escapism of the games that was offered to us as we were young, and I just kind of stick with them throughout my youth, and it was a logical choice growing older, right?
What's more important for you in games that you like graphics, storytelling, the gameplay, or maybe a combination?
I guess in the end, for me, it comes back to the community and kind of the shared experience of playing the games. So it is in the end about kind of multiplayer of it.
What about the single-player games then?
Which are also awesome. There is nothing about games that is not awesome, right? So single-player games also cool. Whatever story-driven RPGs, story-driven text-adventure games. There is nothing to dislike in those either, but for me, just kind of the multiplayer experience is something that drives the medium forward into kind of this new, less explored areas of just kind of playing with your, children or with your parents or with your grandparents. Why not? And I guess this is something that just excites me.
So the future is in multiplayer and socializing in games. Is that right for you?
Well, I hope it is I guess what I'm saying.
Well, we can move it over there. St. Pete, we're here today. What do you think about the city?
A beautiful city, repeat. Awesome times to be had all around, and I'm glad to be here. Thankful for the opportunity.
Glad to have you here. Also surprised you know the cult song about St. Pete. What about the conference? I know it's the first day, but what are your impressions so far? Maybe expectations?
Well, I've met some awesome people all around. I'm looking forward to hearing their talks, to hearing their thoughts on the future of gaming and the future of the industry, and I have high hopes.
Any specific speech you're maybe looking forward to? Somebody you want to listen to?
So there is, for example, the Greg Street, the design director of League of Legends, will be talking about using user feedback to improve your game design. So this is something that, for example, I'm very interested in. And also anything from game design track is something that appeals to me very much.
Well, hope you find it useful. And finally, if you were standing here in my place interviewing yourself, what question would you ask yourself?
Whoa, not sure at all.
I guess you have all the answers then.
Yeah, possibly.
Well, I hope you find more answers here on 4C, and thank you very much, and have a nice time.
Thank you.
So we've prepared a few questions for one of our speakers. Please introduce yourself.
Hello, I'm Ville Rauma from Fingersoft, Finland. So, yeah, nice to meet you.
Nice to meet you too. Please tell me, what's the first game you have ever played, the video game?
I think that would probably be maybe Microsoft Flight Simulator 3. And
It was your very first, right?
yeah.
All right. Which one is your favorite today?
Right now, basically, Divinity Original Sin 2 is like really awesome.
It's amazing. I gotta agree with you there. And what led you to the gaming industry? How did you start?
Well, basically, I was studying in University of Oulu, and we had a training period where you go to a company, and there happened to be a game company in the list where you can pick where you want to go, and I was like, yeah, I want to go there. So that's how I got started.
So they just took you in?
Yeah, because it's like the companies kind of volunteer that we'll take trainees from the university, so you can kind of pick where you want to go. So yeah.
Sounds great. So what is your favorite thing about the video game industry today?
Well, I don't know. It's like it's really hectic, and it's quite kind of free kind of environment where people can really be, who they are, and it's kind of laid back. So I think that's pretty cool.
It generally is. But are there maybe things that make you mad or sad in the today's state of gaming industry?
Well, I don't know. Like, it's difficult to say. Sometimes there are things, but nothing pops to mind right now. Like maybe sometimes like they, especially like huge studios, kind of focus on single thing. You know how it is. Like sometimes there's only World War II games, and next you have only like future mech games or whatever. So it's like always these big trends and less about like innovation and new type of games. So maybe that.
Speaking of trends, do you see any trend surfacing in 10 years or so? How do you view the gaming industry in the nearest future?
Well, long term, like 10 years, I think probably there's gonna be big changes. Like of course VR, AR are big, but right now they're like really new stuff. So it's not really like a big business opportunity right now. But that's probably gonna be big in the future. I think it's gonna take a few years. But yeah, at least that.
So you feel like technologies are going to be the game changer here?
Well, at least with VR and AR, I feel like the experience is so awesome that when you do that, everybody who tries it thinks it's awesome. But right now, it's just too cumbersome and complicated to do. So I think that's the biggest issue there. But yeah, also of course, there's gonna be probably like different trends in the way games, like the kind of like the free-to-play model right now, how it is, probably will change. It's always changing. So yeah.
That's true. But speaking experiences, what do you think is more important in a game? Like the age-old question: it's the graphics, it's the gameplay, the storytelling.
Gameplay, of course. Yeah.
The simplest question of all. Okay. So what do you think about St. Petersburg?
I love it so far. It's first time actually for me in Russia and in St. Petersburg. So yeah.
And what about the conference?
Yeah, it's looking really awesome. It's like well organized, so I like it.
What was the best question you were asked so far?
I don't know which game you are playing right now, of course, because I'm waiting to go back home so I can continue playing.
I completely understand you there. But which question would you ask yourself if you were interviewing yourself?
Oh, that's a hard one. What's going to be your next game? And I couldn't answer right now because we are working on a lot of prototypes and we'll see what it's going to be. But yeah.
Great. Are you looking forward to any specific presentation? Which do you want to listen to most?
Yeah, I did mark a few. I don't remember the titles right now, but they were like interesting because there's a lot of like really cool people here who know like a lot about a lot of things. So yeah. I think for me, maybe on the kind of leadership business track is maybe the most kind of interesting for me right now because that's my job. So, yeah.
Well, you're one of the cool people here, so thank you for coming and thank you for being a part of this.